Welcome to this video on arrays. I will move quickly through the course notes. As we discussed in class, an array is a multi-valued homogeneous data type. So it's a variable that can hold many values. And we're going to talk about ways of accessing individual elements of an array. We're going to talk about how to declare arrays and how to manipulate them. A few important notions of an array. Because an array can hold multiple values, when one is created, you must establish the capacity of it. And once the capacity is established, you cannot the array cannot contain any more elements than the capacity. At any given time, however, it may contain fewer than the capacity. The array in memory it looks as you see in the picture here. With this array I have created 5 variables, and technically the names of the variables are given by the subscripts. So on the bottom you see the terminology used to access elements of the array. So the first element of the array has the name t sub 0, t sub 1, t sub 2. Notice that the fourth element is accessed by the subscript or the number 3, not the number 4. Okay. When you declare the array, you establish the capacity and the part of the declaration. In this case, the part inside of the square brackets is called the size declarator. And this establishes how much space is allocated to hold all the elements of the array. And the actual space in bytes is based upon the data type. Ints take up less space than doubles. As you will see, a double array, each element takes up twice as much space as an int array. It's important to note that an array gives you a collection of variables, and each element is itself a variable, and the variable is always given by the name of the array followed by a valid subscript. Because each element is a regular variable of the data type, in this case int for t, each element can be manipulated in the same way you have manipulated regular int variables. There's nothing special there. So if I wanted to enter a score into my t array, my 5-element array, the first score goes where? It goes into the first position, which is identified by the subscript 0. Array subscripts can be any kind of expression that yields an integer value. So t sub 3, 3 is an integer. If I is an int variable, then we can use the variable. We can use any expression that yields an int. What about, can t sub 0 be a subscript for an element of t? Well, what's the requirement? As long as t sub 0 gives you an integer, yes, that's valid. So how do we input values into an array? If we want to load an array entirely, we put a value into the first element, the second element, the third element, to the last. How is the first element identified? Well, the first element is a variable. What's the name of the variable? The array name. How do you distinguish that variable? By giving a subscript. For the first one, the subscript is 0. What's the next subscript? A 1. Next subscript, 2. The last subscript, a 4. So if you have a 5-element array, the valid subscripts are between 0 and 4, which is less than 5. In C++, if you make an attempt to go outside of the bounds of the array, there's no checking done to prevent that. And in many cases, your program may crash on the spot with a segmentation error. Simple reminder, it's very possible for you to forget that the array elements start at subscript 0. Be mindful of that. Another part of that is if the array subscripts start at 0, and if you have a 10-element array, technically there is no array with an element with subscript 10. It is possible to initialize an array when you declare it the same way we can initialize a regular variable. But notice the difference. For an array, it contains multiple values. Therefore, we must specify multiple values. And multiple values are always specified using the set brace notation. The first element you specify goes into t sub 0, then t sub 1, t sub 2, then t sub 4. If you do a partial initialization, then the initialization begins in the first element, second element. When you run out of values, the remaining elements are initialized to 0. It is possible to declare an array and have the compiler determine what the capacity is. So in this case, we say we have quizzes and we list 4 values. The compiler will say this array has 4 values. This is called implicit array sizing. We're going to stop here, but before stopping, we're going to have a quick little demo, and we're going to go back and declare an array that has this initialization in it. So we're going to bring up our secure shell, and we've already done that. And now we want to go through the array and display each element in the array. And for that, we're going to use the loop. And for that, we're going to use the code that you saw over here. We said if we wanted to walk through an array, we walk through it this way, a for loop that generates the subscripts that we want to use. So let's go to our code here. And when we compile and run this, we expect to see the value 79, 82, 91, 77, 84. So let's do that real quick. We'll compile it. Run it, and we see the values. Now what if we say let's do the values, but let's do them in reverse order? What do you think is required? Tell me, what do you think is required? Well, it sounds like I want the first subscript to be a 4, the next one a 3, etc. So what's required? Change the loop so that it goes backwards. Instead of saying that, we got to say greater than or equal to 0. Because we do want to include 0, the subscript 0, and we're going backwards. Is that clear? And now we're just going to compile it and run it again, and we do indeed see the numbers in reverse order. All right, so with that, we will terminate right now.